Hello everyone, I'm Xingyu from S-Lab at Nanyang Technological University. Today I will present our work, Omegance, a single parameter for various granularities in diffusion-based synthesis. When artists draw, they can decide which parts of an image should have rich details and which parts should remain smooth, so that the main subject stands out. The level of details in a piece of artwork can shape its visual harmony, order, and clarity, influencing how the viewers experience and interpret it while guiding their focus. However, current diffusion models do not have such ability. They generate details rather uniformly across the image, and it's very hard to control granularity locally. Our goal is to make diffusion models as flexible as the artists, to selectively control the level of details. Let's look at the diffusion process. The denoising step can be written at this formula here, where the first term represents the current noisy latence and the second term represents the direction pointing to the clean latency 0. We observe that if we scale the second term, we can effectively control how much high-frequency information is kept in the final output. This observation is the foundation of our approach. Our method, Omegance, introduces a single parameter omega into the denoising step. When omega is smaller than 1, we retain more high-frequency noise, which leads to richer textures and more details. And when omega is larger than 1, we remove noise more aggressively, resulting in smoother output. And there is no retraining, no architecture changes, and it works across all diffusion-based models. If we apply omega consistently across the whole image and throughout all time steps, we obtain a global change in granularity. This means the entire output becomes either more detailed or more simplified, depending on the omega value. Omegance can also be applied spatially. By using a mask, we assign different omega values to different regions. For example, we can enhance details in the foreground while surprising textures in the background. These masks can be drawn manually or generated automatically from signals such as pose, depths, or edges. Besides space, we can also control granularity over time across the denoising steps. In the early stage, omega influences the complexity of the layout, and in the late stage, it controls fine details and textures. And by designing omega schedules, we can flexibly manipulate the overall structure or local details in different ways. To evaluate Omegance, we conducted comprehensive quantitative experiments. Firstly, as shown in Table 1, Omegance consistently outperforms baselines such as free U and scheduler-based methods across key metrics. Secondly, in Table 2, we analyze the high-frequency energy and SSIM. The results confirm that Omegance can selectively enhance or surprise fine details while still preserving the global image layout. Finally, Table 3 reports our user study. More than 93% of the participants correctly ranked the images by their granularities, and over 81% preferred Omegance outputs. Together, these results validate both the objective and subjective effectiveness of our approach. Omegance is not limited to text-to-image generation. We also demonstrate strong results in image-to-image editing, real image editing, image inpainting, and even state-of-the-art text-to-video generation. To summarize, we propose Omegance, a single parameter control for granularity. It works globally, spatially, and temporally, and it is training-free, architecture-agnostic, and lightweight. One limitation is that it does not inherently improve the base model's quality, but it gives user more control over the generation process. We believe this is a step forward in making generative model more user-driven and practical. Thanks for listening.